Hello everyone, welcome to this video. In this video we shall be learning about P group. So here notice that what does P represent? It represents some prime number. So here we consider this P as some positive prime number. Corresponding to this positive prime number we have a group in which so when can we say it to be a P group? So suppose we have some group G. Now the order of this group, if this is a finite group, right, if it has finite number of elements within it, then in that case we call this to be a P group whenever the total number of elements which are present in this group G, they are some power of P. So that means the order of this group G is equal to P raised to power n for some n, right, where this P is some prime number. Another definition is that any group, you can call any group as a P group whenever each element has order which is equal to the power of P, right? So each element here in this group could be written has order which is some power of this prime number P. Right now, why do we study this P group? Because P group have many special properties. These groups are basically easier to understand and classify than other arbitrary groups, right? This is one point. Another point is, why do we study these P groups? It is because in a sense they are the building blocks for all other groups. Why? Because their order, the order of each of the elements, or the order of group in case of finite group, that is a prime number, or it is a power of prime. So therefore in that because it is so, we use them as the building blocks for any arbitrary groups via Silo theorem. Now what are these Silo theorems? We'll be studying these later on in the course, right? So we are not as of now going into detail of these Silo theorems. So let's move forward to see our next point. Moreover, if we have some finite group, for every such finite group, whatever is the subgroup of that finite group, so that subgroup is also a P group. So this is given by Silo theorems, which we shall be studying later on. As for an example, we have been studying about this dihedral group D4, right? This is a group of symmetries of square. This is a P group. Why? Because it has order 8, and you know 8 could be written as 2 raised to power 3, where what is 2? 2 is some prime number. So we have written it as this is a finite group, we know, so we have written it as power of some prime number 2. So therefore in fact this is a 2 group, right? So D4 is a 2 group. In a similar manner you could have more examples also of P group. Now next we shall be looking at some of the properties of these P groups. So let me tell you the properties here in this video. The first property tell us about the center of this P group. Now if we are having some non-trivial finite group, so what do you mean by non-trivial finite group? A group G which is not either equal to identity, right, that is a non-trivial group. And if the order of G is n, where n is finite, then we call it to be finite group. So if we consider G to be some non-trivial finite group, right, whose order is a power of prime P, right, so that means we are talking about a non-trivial finite group such that it is a P group. If that is so, in that case the center of that group would have more than one element. So that means it would have a non-trivial center. What does it mean? The center ZG, that is also not either equal to the identity. It is a some other subgroup of this group G, right? So the center of G has more than one element also present within it. Next thing, what is the center? If you remember, it contains all those elements which commute with each other, right? Okay, so the property second here tell us that if we are talking about groups which are having order P square, so we are fixing here. Otherwise we were saying that any group which is having P raised to power some power, it could be any number. Now we are restricting this power and this number n to 2. So we are just talking about groups which have order P square, some prime square, right? So all those groups, they are abelian to each other. So this is the result. So in the next video we shall be looking at the proof of both of these properties. Well, that is it for this video. Thank you for watching.